All right, lesson four, solution sets of linear inequalities in two variables. We know a lot of these words. We just maybe haven't seen them this way. Linear, of course, is meaning it's going to create a straight line. It also means we don't have any exponents on our variables. Inequality, that's our less than, greater than, less than equal to, greater than equal to, and two variables. That means all of these are going to have an x and a y. So starting by filling in this table, it says consider the pair of numbers with a difference that is less than 6. This is just like lesson 1, was it? So I have an example here, 6 and 4. If I do 6 minus 4, I get 2. And of course, 2 is less than 6. I've given you some starters for a couple more. But on your own, go ahead, finish up so you have a table with 6 pairs. An important thing to note here is that we want it to be less than 6, not equal to 6. So 8 and 2 wouldn't work because 8 minus 2 is 6, but 8 minus 2 is not less than 6. So it would have to be something like 8 and 3, so you get 5, which is less than 6. Fill in the rest of the table, pause, fill in it, and then continue. For part B here, once your inequality, I think this is pretty obvious. X minus y is less than 6, where some value of x minus some value of y will give you a value that is less than 6. If you haven't already in your table, make sure that at least 3 of the pairs are non-integers. And then finally, our solution set for our inequality is going to be similar to how we wrote them in lesson 1. Was that lesson 1? Where it won't go away. Why won't you go away? I'll just move it. Where x, y, an ordered pair, tells us our solution is going to have two numbers such that x minus y is less than 6. And just noting that because this is abstract, we don't have any information, this would be all values would be working for this. It could be negative, it could be decimals, fractions, all real numbers are viable as long as x minus y is less than 6 continues to be true. So this up until now, not anything super crazy. It's just solving an inequality. We're now going to talk about graphing it. So we know how to show it as a solution set. We know how to display it as a table. Let's talk about it as a graph. So you kind of have two steps for plotting an inequality in two variables. One is two variables, so it's going to be on a coordinate plane. Your first thing is to set your boundary line. Your boundary line, that's your keyword here. Boundary line, which is where the line would be graphed if it were just an equation. So if we look at this, we ignore the inequality and just write it as x minus y equals 6. Because this is in standard form, ax plus by equals c, we can then find our x and y intercept and plot them on the graph. You'll see that I've already done that. We have 0, -6, because 0 minus -6 would give us a positive 6, and 6, 0, because 6 minus 0 equals 6. So those are going to be our two. And then it says here we have A and B, two options. If the solution includes the values on the line, create a solid line. So that's going to be whenever we have an equal sign in there, less than or equal to, or greater than or equal to. And if the solution does not include those values, use a dotted line. That's going to be just your less than or greater than symbol. This is similar to when you would use a solid dot or an empty dot on your number line. So this one, because it is just less than, we are going to use a dotted line. So you draw a dotted line that goes through those 2 points. It would be a line for the equation x minus y equals 6, but it's dotted because it's a less than, and that is our boundary line. That tells us where the edge of our solutions will be. After that, we're going to determine which half plane, so that's a new word here, which half plane of the graph is going to be a solution. So what we're going to do to check that is we're just going to pick an ordered pair on either side of the graph to test. So let's keep our numbers easy when possible. So I'm going to use 0, 0, which is on this like upper left side of the graph, and 7, 0, which is kind of on the bottom right side of the graph. So if I test 0, 0, I get 0 minus 0 equals 0. 0 is less than 6. That is a true statement. So that seems like it works. And if I use the ordered pair 7, 0, we have 7 minus 0, which of course equals 7, and 7 is not less than 6. So this tells us the side of the graph we should be taking, the half plane that we are going to take is the one that is up and to the left here. And you're just going to put two little arrows next to your boundary line to tell you that's the side you want to take. And then, and this doesn't have to be pretty, just kind of filling in, just kind of filling in the side of the graph that is a solution. And this tells us that any ordered pair in this shaded region going on and on and on and on and on forever is a solution to the inequality x minus y is less than 6. But it also tells us, because we use that dotted line, that a point along the dot is not a solution. So that is what you should have for this graph. The rest of the lesson, you can use this to help you to do on your own. Get your notes checked at the end, and of course, raise your hands if you have any questions.